Okay, so we did circles and ellipse. Now we're going to do hyperbola and then finish with parabolas, but it looks like really just the focus and directrix of a parabola, since we've already looked at vertex form and graphing parabolas. But hyperbolas are very, very similar to an ellipse. The way I like to think about these is that it's like an ellipse that instead of coming together is kind of opening outwards. So you get those two curves that way. And it's easy to represent because you have the subtraction, whereas an ellipse has addition in the middle so that the two pieces come together. A hyperbola has that subtraction. So they're working against each other, so they're facing opposite directions, so they kind of bend outwards from there. And you get these two orientations, a vertical and horizontal, which we also had with the ellipse, but we didn't really have to worry about it too much because everything could be done horizontal or vertical orientation. But these, because of these openings, we do have to pay a little bit more attention to the orientation. So the easiest way to figure out the orientation of a hyperbola from the graph is just look, oh, this one opens down or up, so it's vertical. This one opens to the left and to the right, so it's horizontal. But from the equation, all we have to do is look at the positive variable. So in the vertical hyperbola, y minus k squared comes first because it is positive, whereas the x minus h squared is negative. So this is vertical because y is the positive variable. If we look at the horizontal hyperbola, that relation is switched in that we have, there it is, x minus h squared coming first, minus y minus k squared coming second, and then you have the a squared, b squared, a squared, b squared here. Just like an ellipse, the denominator is the radius squared in the direction of the variable that it is under. So in the vertical, a goes with y, in the horizontal, a goes with x. But you'll notice, if I'm graphing these, the center is still hk. So again, hk, h for x, k for y. And then I have these radius values, a and b. A in the vertical being my vertical radius b, but I just go from the center, a units vertical, b units horizontal. And then instead of an ellipse connecting those radius values, I get this box. Okay, so I just make a rectangle with a and b. And then cutting through the box, center to the corners of that rectangle are asymptotes. We like asymptotes because it gives us the form of the graph. So we just follow the asymptotes. Okay. And then, at the midpoint of my rectangle, I have vertices. Vertices in the direction of opening, co-vertices in the direction that is not the one of opening. And then I just follow my asymptote. So I start at the vertex, and I follow the asymptote out. Now, these also have focal points. So just here, there's a foci, and the foci, just like in an ellipse, are c units away from the center. And just like in an ellipse, A, B, and C will make a triangle. But unlike the ellipse, C is the hypotenuse now, and A and B just make up the legs. So we get that familiar Pythagorean formula of A squared plus B squared is equal to C squared. Where C is the radius from the center to a focal point, and A and B are the radius values from the center to an outside edge of the rectangle. So I think of all the conic sections, hyperbolas even though they seem to have this more complex graph, are really the easiest conic sections to work with. They're not that varied, and everything kind of aligns the way we would. They've got asymptotes, which are nice because I don't have to plot a lot of points, and a squared plus b squared equals c squared. So that's all familiar stuff. So that's nice. Okay. So you've got two exercises right now on Khan Academy that would go with these hyperbolas that I am going to work through now. So let's go over to Khan Academy. So, let me see if I can make this a little bigger. All right. Sorry, this isn't my computer. Different room, so I had the projector. But it wants us to figure out which of the following graphs can represent the hyperbola y squared over 25 minus x squared over 49 equals 1. Okay. Well, first off, I know that the center is at the origin, and because the y squared is positive and the x squared is negative, I know that this hyperbola will open up or down, vertical. And the vertical radius is 5. The horizontal radius is 7. So I know that the length of this axis will be 10. The length of this axis would be 14. So it's going to be a fairly wide hyperbola. Okay. So I look, and we're just going to measure the A. So if we're doing it, let's write everything down. Center at 0, 0. A is 5, and it is vertical. B is 7, and it is horizontal. And we don't need to worry about the focal point. So let's look at our graphs here. Okay. So A, well, that's not even the right orientation. Sorry for the shaking there, guys. My fault. So we're going to scroll down. B has the right orientation. So let's look at our radius values from the origin. It goes 1, 2, 3, 4, 5, 6, 7 vertical. That's not the right radius. We need it to be 5 to match that 25. Whoa. Apologies there. Okay. C, D is clearly not it. It's horizontal. C works. C looks very nice. It's a wider hyperbola, which matches what I expect from this radius. If I look here, it's 1, 2, 3, 4, 5 there. So C is the one I'm going to go with. That matches all the criteria that we've seen. Yay, we got it right. Next one. Same type of problem. Match the graph. So we're going to do this one a little quicker. So we have x squared over 25 minus y squared over 36 equals 1. This is a horizontal parabola because my x squared is positive, and I know that A is also 5, but it's horizontal this time. B is 6, and it's vertical. So it's going to be a little bit more stretched out. We just need to match up those criteria, those features. And that one actually looks pretty good, except that's on the 6. That's not right. It's horizontal. It's got the right orientation, but that horizontal radius should be 5, not 6. We want this one where that horizontal radius from the center at 0, 0 goes out to 5. It is C. Yeah. Now, going the other way, we have a graph. We want to figure out the equation that matches it. So I look, where's the center? Just like all of my conic sections, I gotta find that center first. So HK, and center right here, origin is at 0, 0. So I'm gonna write that down, center is at 0, 0. And then what's the orientation? Should y squared be positive or should x squared be positive? And because these hyperbola open to the left and right, I know it's going to be x squared positive over a squared minus y squared equal to 1. And then I just have to find the value of a and b. So horizontal radius, the value that goes here, if I look at my center, 0, 0, my horizontal radius is going to be 2. So a is 2, a squared is 4. I don't know my vertical radius, and I don't really have the asymptotes here to figure out. I could draw them in, but that should be enough. Let's see if we can figure it out from here. And we can. The only one that fits, x squared minus y squared. So we can cross out this one because y squared is first. We can cross out this one because y squared is first. This one is 2 on the bottom, which is our radius, but we have to remember it is squared, so it is b that we are looking for as our answer for that one. Huzzah. And then again, same thing, y squared first means it'll be vertical, so we can get rid of a and b, both horizontal. In this case, it has a radius of 5 vertical, but a radius of 1, so for the horizontal, if we were sketching that out, that's going to be a fairly narrow hyperbola. Because it's 10 this way, but 2 that way. So we're looking for a very narrow vertical hyperbola. And the only one that fits that is D. Good for us. Okay, with that, we're just trying to look at the features that are apparent in the equation and match them up. And in the equation, you have a center, HK. Be careful with the ordering, because if y is first, that's still k. And we also have the radius on the bottom, a and b, horizontal radius, vertical radius, depending on which variable it is under. Now, the next set of exercises, the foci of a hyperbola from the equation. They're giving me the equation, which means I have a squared and b squared. The foci are going to be the center plus or minus c along the axis of orientation, vertical or horizontal. So let's look at this one. First, let's find c. So if a squared is 64 and b squared is 32, then c squared is going to be 96. Which means c is equal to the square root of 96, which usually we would reduce, but it seems like that's just what they used in the answer. So we're going to pay attention to the answer choices here. Because x squared is positive, I know that this hyperbola is oriented horizontal, so that I know my foci will be at h plus or minus the square root of 96 with the vertical part of the center left alone. And the only one that works there is a, root 96, 0, negative root 96, 0. The other ones either do not have the right value for c or are changing the wrong part of the center. So this one would be a. plot the foci of the hyperbola represented by the equation, so x squared over 625, y squared over 3600. Again, I need to figure out c. So I know that c squared is equal to 625 plus 3600, which would be 4,225. Yeah, okay. And then we're going to take the square root of that, which I'm hoping is not a decimal. Check my arithmetic real quick. 625 plus 3600 is that, and we're going to take the square root of 4,225, which is 65. Good. So C is 65. That's a radius. So from the center, we need to go 65 units along the axis of orientation, which we can see from this hyperbola is horizontal. So from the center, 10, 20, 30, 40, 50, 65, we have one there. That there. And then in the other direction, negative 65 would be our other focal point. That's all it is. Find C and then measure from the center of the hyperbola in the direction of orientation to that focal point. This one is the same. So again, we need to figure out where they are. This particular hyperbola, because y squared is the positive, is going to be vertical, so I know my focal point are going to be hk plus or minus c. So I need to find hk plus or minus c. Looking at my equation, I don't have h or k, so I can assume there's 0. So we need 0 and 0 plus or minus whatever value we get for c. We've identified the center. And then we use a squared plus b squared equals c squared. So here I know c squared is equal to 25 plus 48. 25 plus 48 is 73. Yep. So we know c is equal to the square root of 73. Check my answer choices real quick. That's exactly what they used. They didn't reduce it all, so we're not going to worry about that. I need A. A is the only one that fits. 0 and then 0 plus root 73 and 0 minus root 73. So we're going to select choice A. Okay. And this one again just wants me to plot the focal points. So again, I need to figure out my radius. The center, 0, 0, again. We have 36 and 64, so c squared is equal to 36 plus 64. That's 100. Means c is equal to 10. And because my hyperbola is vertical in orientation, I need to go 10 units from the center along the vertical axis, so 0, 0, 2, 4, 6, 8, 10. Let's move that down there. And 0, 0 minus 10 in the vertical direction is going to be negative 10. So right there, and that's it. Okay. The last exercise, equation of a hyperbola from features, I will do in another video. But it's just like the ellipse, so look for that later in the week. And then we'll look at parabolas as well. And then in May, our focus is just going to be sequences and series, mainly the notation for sigma, because that's what we look at in calculus. And we'll do a little bit of limits and then continuity in the first derivative. That's it. Hyperbolas and parabolas this week. A lot of you have already finished those exercises, so keep up the good work.